Hello, everyone. So now we switch gears from NLP to computer vision or CV. So my name is Beng, and I lead the Computer Vision Hub in AI Singapore. And today I'm very excited to share about PeekingDuck. And this should take about half an hour. I'll start with an overview and some demos, explain how it works, how you can use it, and even customize it for your own project. So why did we create this thing called PeekingDuck? Well, we've worked on many CV projects for industry, and what we found is that while the types of CV problems are very varied, many of these projects actually share repeated code, such as reading from a video or an image. And in some projects, even a pre-trained computer vision model for object detection or pose estimation can be reused. So we got tired of rewriting our pipelines, and we decided to build this PeekingDuck framework to cut down development time for future projects. Raisa, maybe you could share my screen now. Thanks. Okay, so let's find out more about PeekingDuck. So you can find PeekingDuck quite easily. Just go to Google and look for PeekingDuck GitHub. And it should be the one under the AI Makerspace GitHub repository. And the PeekingDuck is a double E instead of a single E. So why do we call it PeekingDuck? Well, if it's a single E, then it sounds like a restaurant dish, so it's easy for you to remember. But there's actually a deeper meaning behind this. The name PeekingDuck is actually a play on two words, peeking, because we deal with computer vision, and duck in duck typing, because we are using Python, which is a dynamically typed language, and that's called duck typing sometimes. And this is our PeekingDuck logo, which we think is pretty cute. So right now we have tested PeekingDuck on 3 Python versions, Python 3.6, 3.7, and 3.8. And we have also tested it on 3 operating systems, Mac OS, Windows 10, and Linux. And most importantly, PeekingDuck is under the open source and permissive Apache 2.0 license, which basically means that you can download it and you can do whatever you want with it. And without further ado, let's go to the first demo. So the first step over here would be to install PeekingDuck, which I have already done. So I will skip that and go on to the second step over here, which would be to create a project folder. So tonight is DataScience SG, right? So I'm going to make a folder called DSSG. I will go into it. And there's this special command called PeekingDuck init. Maybe I'll just zoom in a bit more. PeekingDuck init, which will initialize an empty project. So I will just run that. Right, so you can see that it has created a folder, and let's just open it up. Under desktop, under DSSG. So we have 2 new files here. One is a run_config.yaml file, and another is a source folder. I will talk more about these 2 later on. Right, so the next step, actually, you can run the demo immediately. So I will go ahead and run the command PeekingDuck run. The first time we do this, it might take a bit longer because we need to download the model weights. But I've done that previously, so it's much faster. Right, so you can see that this demo is running live right now. What you are seeing actually is object detection, where the CV model, it detects me, a human object, and it predicts my location. And you can see the yellow bounding box or the rectangle around me actually moves along with me. And yep, so this is basically the first demo. And if you have a webcam, once you download PeekingDuck, you can run this almost immediately, like what I've done. So next, I will explain a bit about how PeekingDuck works. And there are 2 important concepts that you need to know. The first, right, is this thing called nodes. So nodes are the building blocks of PeekingDuck. And there are 5 kinds of nodes in PeekingDuck. The first is the first 2 are the input and the output nodes. And the input nodes basically deal with different inputs like videos or images. And the output nodes deal with tasks like showing the results on the screen or saving it out. And there is also a model node, which is basically our bread and butter, the AI model, the computer vision model. And there's also the draw category, which is responsible for drawing the results. And last of all, there's this special category called Debo, which I will talk about more later on. So nodes are the first thing you need to remember. The second thing that you need to remember is pipeline. So a pipeline is basically a chain of different nodes combined together. And in the demonstration just now, right, which I will maybe just open up on the side, it's still running. So it's actually, this demo is made up of 4 nodes combined into one pipeline. So the first node is the input.live node, which reads from my webcam and it produces this image frame called IMG. And this IMG goes into a data pool. And the next node in line is a model.YOLO node. This is the object detector, the CV model. It takes in the image frame and it makes a prediction of the bounding box of where I am and also the label. In this case, I'm a human. Next, it goes to the third node, which is a draw.bbox node, which takes in all of this and basically just draws this yellow rectangle around me. And the final node would be the output.screen node, which is responsible for showing it on the screen so that all of us can see it right now. So I'm going to end this demo right now. Right, so I think you have an understanding of how nodes come together into a pipeline now. So I will revisit this node category called Debo. Our CV model node, it does the heavy lifting. And the Debo node is just something that, it does something a bit more with the result. And you can see in the description here, we wrote that Debo nodes are methods that dabble with model predictions to produce useful results. There's another reason why we call it Debo node. And if you, let's look at one image here. So this is actually a duck that is dabbling. And when it's doing this, right, it's actually poking its head under the water to look for food. So this is another reason why we call it Debo. And now that you know about nodes and pipelines, let's move on to the next section, which is how to change PeekingDuck nodes. So if you go to our GitHub and scroll down to this section, you'll be able to see most of the documentation for PeekingDuck is actually at our Read the Doc site, which I will go into right now. Right, so just to orientate you guys, this is our Read the Docs page. There are different sections on the pane on the left. There's an introduction section. There's a getting started section, which we'll run through more later on. There's a section on the different CV models that we have. There's a section on the use cases. And finally, there's a section on API documentation, which we will go through very soon. So let's see. Okay, as a recap, now, just now we ran this special command called PeekingDuck init, right? And just to refresh ourselves, when we ran that command, 2 different things were created, this configuration file and a source folder. So let's go into this configuration now. I have opened it up on my Visual Studio Code. And yeah, you can see that actually all the 4 different nodes that we use in the demo are shown over here. And now I will show you how you can change it. So instead of object detection, I want to try pose estimation. So I'll use our PostNet human pose estimation model. And now instead of drawing a bounding box, I will draw poses, key points. And let me run it again. Right, so something different is happening now. You can see that this is not a bounding box, but it's a human pose estimation. So basically, the AI model can detect my eyes, my nose, my ears, my shoulders, elbows, wrists, hips. I can't show you my legs, but you get the idea. And I'm going to quit this demo. And I just want to illustrate, basically this example really shows how easy it is to use PeekingDuck, because simply just by changing 2 words from YOLO to PostNet, from bbox to poses, I've switched the task completely from object detection and human pose estimation. And the next thing I want to show you is how to deal with saved videos. In the last 2 demos, we were running a live demo using the input.live node, and it was basically reading from my webcam. But now I want to work with a saved video, and one that I would like to use is this one. So it's a short 5-second clip of two ducks walking around. As you can see, we really like this duck theme. And yeah, let me just move it into a folder. Right. So in order to know what nodes we want to use, okay, maybe I'll explain a bit more as well. So the task that I want to do, right, is to work on this video where I want to detect these two ducks as objects and draw the rectangular boxes around them and also save the resulting video. So in order to know which nodes I need to use, I need to go to the API documentation in our Read the Docs page at the bottom left. And let's go to input first. And just now we were using input live, right? Now we need to use input.recorded because it's the node that's responsible for reading from a directory. So let's click on this node. Yeah, so for every single node, basically, we are going to describe what inputs it takes, what outputs it gives out, and also the configuration for that node. So in this case, I think I can go with the default configurations. The only thing I need to change is the input directory because I've moved it to a certain folder. So let's go back to here. Instead of live, it's going to be recorded. And I will change it to input directory. And hopefully I remember this correctly. On my desktop and under input. Okay. The next thing that I want to do is to change this node. So it's a duck, so there's no human pose estimation. So I'll change it back to the YOLO node and a few other things I need to change. So let's go back to read the docs. And now the right section will be under model, where you can see right now we only have 4 models, 2 for object detection and 2 for pose estimation. But over the next few months and the next few years, we are going to add more and more to our model zoo. So let's go into YOLO mode. And yeah, you can see that right now our YOLO node is capable of detecting objects from 80 categories. So you can actually change the category by clicking on this. And this is basically a table of the different categories of our models. And looking at the YOLO category, just now it was detecting me as a person, so it was category 0. But now we want to detect ducks, which I guess is a bird, so we'll change it to category 14, 1-4. And we also need to know where we want to change, how we want to change that. So that would be under this configuration called detect IDs. So I will just go back to this and change it to detect IDs 14. Okay, then the next one, no human pose estimation. I just want a bounding box, so I will just change it to B box. And for the very last one, which is the output node, I will change it to, let's see, under output, we have a CSV writer, which is not what we want. Output.screen was for showing on screen, which we did already. I want to save it to files, so I should be using media writer. And the only configuration that I need to change is basically the output directory, where I want to save the file. So let's go back to Visual Studio Code and change it to media writer. And my output directory would be also on my desktop, but this time I will save it to a folder called output. Okay, so if I have keyed in everything correctly, it should run without errors. Let me just clear the screen and run it again. Right, so it's actually running on the video now, and you can see that it shows the progress over time. So when it reaches 90 or 100%, then we know we are done. Almost there. Maybe I'll just open up the output folder. Okay, you can see that it has finished running over here. So let's see output folder. And we see that now there is a video here. And yes, the object detection model does manage to detect these two ducks. Okay, good. So one other thing we can try for fun is to try working on another image. So let's try it on a real Peking duck. Do you think the model would be able to detect this as a duck? Let's find out. So I will move this into the input folder. Yep, that's the only file inside. Let me just clear this and run it again. Right, so this time is very fast because it's just one image, so one frame compared to a video with many frames. And if we go back to the output folder, okay, nothing was detected, which I guess it means that a roast duck is not the same as a live duck in the eyes of our model. And this basically covers how you can change nodes and node settings. Now, I have a question here. What happens if you change this from draw.bounding box to draw.poses? Will there be an error? Let's find out right away. I'll just run it again. Okay, looks like there was an error, right? It says that the nodes in this pipeline do not form a proper channel. And the reason why is because this draw.poses nodes, this is for drawing the key points and the edges of my eyes, my nose, and all these different positions. So it requires key points and key point connections. But the AI model used in this case is not a human pose estimation model, it's an object detector. So it produces stuff like VBox and VBox labels, but not what the draw.poses node requires. So as a result of that, it doesn't work. So we implement this check at the beginning just to make sure that the nodes that you are using are the right ones. And I guess we can always come back to this diagram and visualize and think, oh, this is how all the different nodes come together in the pipeline. And the inputs of one node needs to be the outputs of another. For more information on what kind of inputs and outputs are required, you can simply come to our API documentation here, and you will be able to see the inputs, outputs, and the configs of each node. Okay, so I think now you've seen gotten a quite a good understanding of what PeekingDuck can do. Let me show you other additional features. The first one I want to show you is building custom nodes. So in some cases, you may need to create your own custom nodes. For example, sometimes you may want to take a snapshot of a video frame, like people fighting, for example, and then post it to your API endpoint. Or in another scenario, maybe you have a model that is trained on a custom data set. For example, something that has been trained to detect license plates, right? And you would like to use your model with our PeekingDuck's input, draw, and output nodes. So we made PeekingDuck very flexible such that you can combine your nodes with our nodes. And I won't go through all the details here, but at a very high level, what you need to do is to create a script, a Python script for your node which has an init and a run function. That's number one. Number two, you need to create your own configuration file with the input, the output, and any special configurations. And number three, once you've done that, just add your custom node to our run config file and run it. And that's basically all you need to do. The second additional feature that we have for PeekingDuck is what we call our Python API. So in some cases, you already have a project where you have existing code base, but you might want to use PeekingDuck because of some of our features or nodes. So what you can actually do is to import PeekingDuck into your Python code. As you can see in this example over here, where you can import PeekingDuck and use different nodes to extract whatever you want out of it. And this is just a snippet, but we also have example here. You can even use PeekingDuck with Jupyter Notebook, or in this case, we have this demonstration on Google Colab that you can try as well. Yeah, so it's pretty straightforward, and all the instructions are over here. The next thing I want to cover is what we call use cases. So let's go back to introduction. And these are what we call use cases, where basically my group in AI Singapore, we are interested to use computer vision to solve real world problems. And that is why we have created these use cases for PeekingDuck, which are basically a special combination of nodes to tackle specific problems. And perhaps the best way to show this is to give you a quick demo again. And this will be the last demo for tonight. So let's try this thing called zone counting. Yeah, so each of the use cases, we have described how it works and how you can use it, but no time to go through. So I will just demonstrate it to you by copying the config file for that and pasting it over here. And just a note, you can see that this use case, right, there's a lot more nodes compared to the previous demo, right? You have a double node and a zone count node and a few other things. So I'll just clear my screen and run it again. Right, so this time round, we are doing what's called zone counting, where, okay, if you take a look at below me in the box, there's this little dot, right? And on the bottom left, there's a legend which says zone 1 and zone 2. So zone 1 is this area bounded by the cyan or turquoise box rectangle, and zone 2 is the one bounded by this dark orange or red box. So right now it says that there's one person in zone 1, that's me. But if I start moving over to the other side, then I go to zone 2. And if you have a lot more friends and they all come in here, you can see basically it will just keep adding the numbers in the right zones. So basically I just define the zones over here. And in this case, I just define two very simple rectangles. But you can actually change this to be a triangle or a pentagon or hexagon or even more and more sides, right? So for we think that this will be useful for certain scenarios, like for example, you want to detect how many people are waiting at the bus stop, for example. So if the bus stop is over here, you just draw a shape around the bus stop, and then the object detection model, it will just detect the number of people within the bus stop. If people are walking outside the bus stop, it will not detect it. And yeah, so this has many applications in, like, for example, retail analytics or checking if certain areas are very crowded. And that is one example of a use case. Now I'm going to show you other use cases very briefly. The first one is probably the one that we are most well known for, social distancing, where we use human pose estimation and we estimate the distance between two individuals. And if they are too close, we will say that they are too close. So this was something that we deployed for HP Singapore last year in their production plant. And yeah, so that's another use case. A further use case would be an extension of that, where instead of just detecting the distance between individuals, we also check to make sure that we check whether they are in the same group. And this is quite useful for sometimes the government regulations, 2 people per group, sometimes it's 5, sometimes it's 8. So we can just adjust this accordingly. So these two use cases are what we developed to try to support the fight against COVID-19. And the last one over here is object counting, which is a much simpler version of the zone counting, which I showed you, where there are no zones and it just counts the number of objects, which can include like humans, cars, motorcycles, animals on the screen. Yeah. And right now we only have 4 use cases, but we will be adding more nodes and use cases over time. So I'm wrapping up this presentation. Just want to say that my team at AI Singapore, we are committed to maintaining PeekingDuck and continue to keep it open source and improve it over the years. As you have seen, one of the main strengths of PeekingDuck is its modular node system. And with this, PeekingDuck is actually scalable. And we are able to add more nodes and better nodes over time. So stay tuned for our latest developments. In fact, I think most likely we will do another release of new nodes and use cases by November this year. And also, as you know, there are many developments in the field of CV. Most recently, those of you who are following, there's vision transformers, and there's also MLP mixers. both of which are not using the typical convolutional neural network or CNN architecture. And we are constantly surveying the scene, and we will add new models when the time is right. In the meantime, we encourage you to try to use PeekingDuck to install it and start our repository over here on the top right. And if you like it, recommend it to your friends and colleagues as well. You are also welcome to join discussions about using PeekingDuck either in our GitHub discussion board or AI Singapore's community forum. And last of all, to conclude, we have benefited from using PeekingDuck in our industry projects. For example, we recently had a human pose estimation project with Genesis Gym to provide feedback for exercises such as bicep curls. And we found that using PeekingDuck really shortened our development time. We are open sourcing PeekingDuck so that you, the computer vision community, are able to benefit as well.
Is a slide presentation going to be shared? So for the SGNLP team, who has slides to share just now, so I think we'll share the link to the description under the YouTube live page. Yeah. So whereas for the CV Hub team, Liping, I guess you didn't have any slides, so I guess the best way, for them to reiterate on whatever resources you have shared is of course the GitHub page.
Yep, that's right.
So, right, thank you for that. Can you show the bounding box on live video while at the same time output the video to file? Yeah, so this is a parallel job thing. So is this possible?
Yep, that's a good question. Yeah, so it's possible. You can just use the output.screen and the output.media writer notes both at the same time. I do this quite often as well.
As the main resource that you have shared today, which is the GitHub page for PeekingDuck, and of course, I think it will be of vested interest for your team, for people out there to contribute to your repositories. So perhaps what if anyone is enthusiastic about contributing to your project, what are the first few things that they can look into to perhaps contribute to your GitHub repository for PeekingDuck?
Oh, that's a good question. Okay, I think the first thing you can contribute is to try to run it and see if you like it. And if you run into issues, you can either create an issue on GitHub or discuss in our discussion forum on GitHub or AI Singapore community page. And yeah, so that's the first thing you can help with, to basically find any bugs and try to stem them out. And another thing also that I think the community can really help is I talked about custom nodes, right? So I think the ability of PeekingDuck to let people create custom nodes, basically it just lends itself to a lot of imagination and creativity, right? So you may want to create for your own project some custom nodes to, I don't know, do a certain task, like I can't think of any for now, but let's say you do it and it's quite nice. So what we actually encourage you to do is we have provided links for you to actually share your custom nodes code either on the discussion board or the community forum, and you can share it, and you can tell people how you what this node is for and why you created it, and if people find it useful and they like it, then they can also use it as well. And as I said, we're also trying to increase the number of nodes, useful nodes over time, right? So if we also start taking notice of the nodes you've created, and if you find that it's a feature that we don't have but we would like to have, then we will contact you and we can work together to make it a real node in our PeekingDuck package. Yeah.
Yeah, perhaps the SGNLP team would like to perhaps answer the same question if they would like to in a sense contribute also to the efforts of this NLP community within SG. How would they do so? Because I see from the SGNLP page, within each of the model cards, there are links to the public GitHub repositories and even the research papers. So yeah, perhaps what's the best way for SG and NLP practitioners all around to contribute to the project that you are doing?
Yeah, thank you, Raisa. I'll take this one. Yes, so we highly encourage the community to engage, and we want people to be involved. At this point, people can use the platform and give us feedback. That will be very helpful. But in the very near future, we plan also to move to the second stage of having people contribute to the platform. And for that, we'll open up workshops that will explain how exactly to contribute. And we plan to add that section also to the documentation for people. So look out for that. We'll also announce that when that happens and make one of this workshop live for people to join. And the idea would be that if there's a research group or even individuals that have developed models that they think can benefit the community, we are open to host those models. And as John mentioned, a lot of the work we did was to create a unified API and easy to use for all the models that we've implemented and uploaded to our website. So the work that we would be happy to collaborate with researchers and practitioners is to implement that API or for their model that they wish to share with the community, and then we can host it on our website under one of the existing categories or maybe a new category if you have something exciting to share.
All right. Thank you for that. Thank you for the answer, Alan. And there's, I guess, again, another question that popped up for the SGNLP team by Zeki Wong. For the SGNLP package, how easy it is to perform fine-tuning or additional training of the base models provided with our own data?
Yeah, I can take this question. So so firstly, we have written the preprocessors for like the data sets that the paper used to train the models. So if we are training on those data sets, it will be quite simple because all the functions and are written and the training function is there as well. But if you are using your own data and it's not in the exact same format, you might need to write your own preprocessor for it. So that will take additional effort, and usually, it might not be so straightforward.
Just to add to that, because some of the models, the way they were built, require a specific form of structure for the data that they take as input. So the idea for this preprocessor is just matched. If your data comes in that form, then you wouldn't have to work hard. But the preprocessor, what it does is just adapt to the structure that the model was built to take in.
All right. Thank you both, John and Alan. And I guess we're coming to the end of the session, but of course, before that, we can answer one last question by Lauren. All right, and perhaps William can take this. What are some upcoming releases by AI Singapore's Makerspace?
Yeah, I assume that's not Makerstudio. Yeah, it's Makerspace. Yeah, I think. Thank you, Lauren. And Rizal, as Alan mentioned before, right? Specifically for the NLP team, we have an upcoming release of some NLP packages that are designed primarily for languages of Southeast Asia. So we are currently working very hard with our regional partners to, sort of like plug this gap. The fact that many of the Southeast Asian languages are of low resource in nature, like, as compared to the high resource languages like English and Chinese. So stay tuned. Hopefully, you will hear from us sometime towards the end of the year.